Hello friends, welcome to JavaFx 3D tutorial. In this sub-series, we are discussing about transformation, and in this video, we will see how to use rotate transformation. So in rotate transformation, the local coordinate space is rotated about a pivot point. So we already talked about translate transformation. The same way here, the local coordinate space itself is rotated about the pivot point. Then in the rotated coordinate space, using layout X and layout Y, the shape will be plotted. Nodes points are mapped to this new rotated axis. So let's state that this is our window or stage, and we will assume that this is the x-axis and y-axis goes like this. So usually in JavaFx, the top left corner is the origin, and we will assume this origin as pivot point as well. Let's state that our rectangle is shifted in x and y coordinate, and here is the rectangle. Here I'm not drawing the 3D shapes, so for easy explanation we are taking a 2D shape, but you can apply the translate as well as rotate, and in the next coming 2 videos we will see 2 more transformation. All those can be applied in 3D space as well. Alright, now let's state that we are going to rotate the shape in 45 degree. So when the coordinate is rotated, so X will be here, and so I don't want to crash this demo area, I mean the text area, so that's why I am keeping it smaller, but it will extend like this. So X and Y coordinate, and if you see the rotation, if you rotate it in 45 degree, it will be done in a clockwise direction. And then if you state that the Y is 20 and X is 25, then after this rotation the rectangle will be placed in the same coordinate space. Here if you see the coordinate is rotated, then X 25, this is the X, right, translated coordinate X 25, and in Y, sorry, in Y it is 20, X it is in X direction 25. So this is X, let's state this is 25, and in Y it is 20. Then we will plot the rectangle here, and if you see the rectangle is rotated about this pivot point. So 45 degree it got rotated, but it got rotated based on the translated coordinate. So let's consider there is one more object, cylinder. Even though you rotate the xy coordinate, if pivot point is here, the rectangle or this cylinder will be rotated about this pivot point. So in that case, the cylinder will do a self rotation, and you will see 45 degree rotation here. But here pivot point is shifted, it is in the origin. So if you move the pivot point here, and then if you perform rotation, you will see that a rotation takes place about the pivot point. That means the coordinate itself moves to this pivot point, then rotation takes place. So that's all here about the rotation. Now we will proceed. The rotation can be in any axis, x, y, z. So whatever we explored here is rotation about the z-axis. So you saw this is x-axis, this one is y, and z-axis is pointing towards you. So we did a rotation about the z-axis, but rotation is possible in x-axis as well as in y-axis. So later we will do the rotation in all three axes, x and y-axis, when we go to 3D shape and animations. But before going to 3D shape animation, it will be vital to understand how translate, rotate, and scale transformation works in 2D coordinate space. Then you can map it to the 3D coordinate, and we will go to more advanced topic of animations. JavaFx provides rotate class, just like translate class. It provides a rotate class. That means rotate is derived from transform class. So just like translate class, JavaFx provides rotate class to perform the rotate transformation. Rotate class depends on the following properties. The pivot point. So as already told, the rotation is based on the pivot point, and you can specify the pivot point in a three-dimensional space using the properties pivot x, pivot y, and pivot z properties. After that, we can tell what is the rotation axis. So based on this rotation axis, the rotation will be performed. So origin of rotation depends on this pivot point. Then under what axis you want to rotate, that depends on the rotation axis. Since we took here two-dimensional space rectangle, we rotated it in z-axis to see the effect. But if this object is a 3D box or a cylinder, then we can even try with rotation in all three axes. So we will revisit this rotation, and we will try to rotate the object in other rotation axis when we move on to the animation series. Next comes the rotation angle. So the rotation angle is measured in clockwise. If you see, since we take the axis in Java dimensional or JavaFX dimensional space, it will be in the top left corner of the window. So the rotation takes place in clockwise direction. So if you specify rotation angle as 30 degree, and the axis will be shifted in 30 degree space. Alright, in this video we will rotate the ellipse in its center and shift the origin via pivot points. Then we will place the pivot in a different location and try to rotate the ellipse. So we will do both. So first time we will keep axis towards the center of the ellipse, and the next time we will shift the pivot point to a different location. Then we will try the rotation. So if we do so like that, when you rotate the ellipse in 90 degree, and if a pivot point is in center, the ellipse will be rotated like this in 90 degree, right? But if this is the ellipse and pivot point is somewhat here, then rotation takes place this way to 90 degree, because the pivot point is at different location and the object is shifted. So rotation is about this pivot point. So you can think of this is a campus and you are drawing a circle. The pin of the campus is the pivot point and pencil is here, and that denotes the object. So if you rotate 90 degree, whatever you draw, you will be drawing an arc, right? So the ellipse center will be towards the arc, so it will get rotated this way, right? But in self rotation, since pivot is towards the center, the ellipse will rotated in a self rotation fashion. All right, now let's look at the code. So here what we will do, we will open a loop that runs for 11 from 0 we are starting, so 0 to 11, maybe 12 times. Then inside the loop we will create a ellipse shape. Then we set color as blue violet. Then we set radius as 170. Alright, so set radius x and set radius y. Since this is a ellipse, we can set the max and min radius that forms the ellipse. So if this radius x and radius y both are same, then we will end up in drawing a circle, even though we use the ellipse object. Next, here we access the set stroke property. So the set stroke property will define the outer line for the ellipse, and that outer line will be in a black color. So this will be the ellipse, the outer line will be in black color and fill color is in blue violet. So the ellipse will be filled and it in this blue violet color, and the outer border will be in black color. Stroke width is 2, that means we provide somewhat thicker border. If you increase this to 3 or 4, you may be setting even more higher stroke width. Set opacity 65. So this way, if you draw multiple ellipse on top of each other, you will see the underlying ellipse also, because we are setting the transparency flag. So if opacity is 1, then the overlapping ellipse will hide completely the underlying one. But here we set a transparency flag. Opacity is 65, that means there is some transparency and you can see through the bottom ellipse with the overlapping top one. So there is a transparency which we set here using the set opacity. Finally, we are using the rotate transformation. So remember, this code runs on a loop. First we create the ellipse and we set some set of properties. Then we create the rotate transformation object. After that, we are setting the angle property here. So the rotation angle, if you see, from I, we are multiplying it by 15. So that means first time there will be 0, then 15, 30, 45. Likewise, we are rotating it till 11 into 15. So up to 165 degree, we are rotating starting from after setting the angle. We perform the rotation, say for example. So each time we are shifting this x and y axis. First time 15 degree. Second time, so y is perpendicular to this x, so you can imagine each time y also will shift. Here we are showing just 2 only. First time it will be 15, ellipse will be drawn. Second time it is rotated to 30 degree, ellipse will be drawn. So this is at 30, then this is at 15. So likewise, we draw the ellipse, and remember we set transparency flag also. So if this ellipse is overlapped by the 30-degree ellipse, you can still see some part of the 30-degree ellipse because of the transparency property. So that's what we are doing. So in each loop we are incrementing the rotation by 15. Then we get the transformation for the ellipse, and we will be creating 15 ellipse. The loop runs for 12 times, 0 to 11, so 12 times. So we will be creating 12 ellipse, and for each ellipse we will be getting the transformation and adding the rotate transformation which we create here. Finally, we get root. Root is a stages root. So in scene graph we retrieve the root and we retrieve the children and we add the elliptical node. And remember, this elliptical node already contains a collection that has the transformation. So we have only one transformation at this moment, and even though there are 12 ellipse object, and each ellipse object will have only one transformation, rotate transformation, but we add all these ellipses to the scene graph root. So that's all. Finally, once JavaFx draws this, you will be seeing 12 ellipse rotated in the center. Alright, now let's go to the demo and see how it works. Okay, this is our previous example, translate transformation. Let us copy this and paste the new class. Here we will name it as 06. We will name it as a rotate transformation. So the class is ready, and we will remove the code from our previous example. We will remove all unused imports. So as usual, we prepare stage and show it. This time we have stack pen. You can also use anchor pen. And scene, our scene size is 600,450, and we name it as rotate transformation, and we show the stage. Next, we will start our loop. And for demo purpose, first we will draw one. Ellipse is from JavaFx scene shape ellipse. Color, we will take it from paint. So inside the loop itself, we will perform the rotation, and this was already explained in the slide. So the rotate transformation comes from JavaFx scene transform package, and we are creating the instance of rotate. Then we are setting the angle as well as a pivot point. So since we told we will keep pivot point as the center, we will delete this. We don't want to shift now. Let the ellipse be at the pivot point be at the center of the ellipse. So if it doesn't specify the pivot point, it will be located towards the ellipse center. So alright, we created the rotate transformation, we set angle, we added the transformation to the object, ellipse object itself. Next, we need to add the shape. So remember, this will run for 12 times. For now we kept only one. We'll run this. So this is our ellipse, and you can see the outer border is in black color. We set stroke of width 2 and the color is black. This we already saw in 2D JavaFx 2D itself anyhow. So this is the ellipse. Now we will keep it as 2. Now there will be 2 ellipses, and if I run it now, you can see 2 ellipses. So this is the first one, this one is the first one, and you can see the second ellipse which is rotated towards the center, and rotation angle is 15. So you can see both the ellipse because of the transparency which we set it as 65. So when you are experimenting the code, you can change this value and see how the transparency is working. So if you set opacity towards one side, that means if you say 0.95, then the ellipse will be more opaque. So if you set the opacity as 0.25, then transparency will increase. So for now, with the experiment, we just kept 65, which looks decent. Now we will go ahead with all 12 ellipse, and we will run the code. And you can see that we drawn all 12 ellipses, and you can see how it got rotated. So this is our final ellipse, and from the outer rim you can see all the rotated ellipses. So this may be our initial ellipse. After that, each one got rotated, and this is our final ellipse, which is staying in the top, overlapping all other ellipse. So this is 0 degree, 0, 15, 30, 45. Likewise you can count on, and this will be our 12th ellipse. Alright, here we performed a self rotation. Now we will just shift the pivot point towards x-axis. So I into 5, each time we are shifting the x to 5 unit, so the pivot point changes, and when pivot point changes, the self rotation will slowly shift and object will rotate with a pivot point. So we will run this, and you can see how the rotation got changed. So this will be our initial, and since pivot point is shifting, you can see this is growing with this x direction because pivot point is shifting this way, right? So you can see the outer rim or right side rim, how big it is and how it is compressing towards the left side. All right, so now we saw rotation about pivot point. That's all here in this video. Thank you for watching. Bye.